Okay, 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 okay. 1 second, guys. So yeah, so we continue with this video. So basically, this is part of the Singi protocol: N for November, S for Sarah, I for Indigo, G for Gold, I for India, I for India. So the first video was talking. Last video was talking about my housing status. Today again is and the council and 10th of May 2026. The time now is 11:23 a.m. So I'm here saying I'm in Nigeria. I'm not British. I'm a Briton because I've been in the UK for so long under the UK law, but I'm not British. I don't have a British passport. And I'll gladly say, I'll not get one because I'll still be my own passport system. I'll still be my own passport system. For people that come here. So basically, my section 204 declaration of when it comes to denying me a housing without using section 184, was one of the most mistakes they didn't even know was a mistake, and I love those kind of mistakes. Anyway, using legal life. So anyway, so this is my peer-to-peer model of networking, and the point I see here is that there is static, dynamic, bus, um, ring topology. This let's start from the bus topology here. Here, you can see that it's basically the bus wheels. Basically, it's like a floor plan. And the thing is, because it's like a floor plan, it is a floor plan. The basically duck typing. If you know what duck typing is, if it's a duck, if it quacks like a duck, if it looks like a duck, it is a duck. If it quacks like a duck, looks like a duck, it is a duck. So I'm using duck typing in this kind of sense of the word, but it's not really duck typing. It's like a concept that uses that allows you to introspect objects and perform operation on data or streams of data, in the world. So if you understand what I'm saying here, in Sigi, no noise, no signal, uh, no noise. I mean noise, no signal, and signal refers to four states of this topology. As you can see, this bus topology is like a flow plan, So the nodes or the circles represent bus wheels, and they are you're looking down at the bus. So you're looking down everything. So you're looking down on the bus wheels, you only observe the bus wheels, and it's a networking. So it's like the bus topology, how you move data across the network. I'm not sticking to bot topology in this video, but the idea is here I want to discuss is how I'm gonna have a 2-to-1 public to private key mapping, 2-to-1 public key mapping. Because I'm trying to have the oral seal, 2-to-1 public keys for Insigi. So 2-to-1 public keys represent a system of public to private keys. So, for example, you have two nodes, two circles representing jobs, and one. So this is a centralized system. This is a decentralized system. But this one on the edges does decentralized jobs. So the circle does decentralized jobs on nodes or tasks. And by doing those tasks, you have things that are intersected, but they can do decentralized and decentralized tracks. So they are like a sparse. So they can, because the circles can do centralized. No mark here can do centralized and decentralized tracks. And what to express here is that, let me take a screenshot of it. What I'm trying to express here is that the bus topology is a topology if it's computers or servers in the real world and you want to I'm trying to map the topology of the buses to the real world architecture. So to what infrastructure. So where things are. So when food is coming. Basically it's a flow plan. Because mapping this to a floor plan is can show that it's not disconnected. You always have a service that's open. It's like a network service. You always have something that's especially when distance. Because if something disconnects, it can reconnect it. So that's the idea. The concept is here is that you use this topology of floor plan. It doesn't matter if it's a star, ring, bus. You have kind of a topology, and topology is kind of ensure that you have something you can connect to or disconnect to or address based on the Nsigi protocol. So Nsigi protocol is N for November, S for Sarah, I for Indigo, G for Gold, I for India, I for India, and it's a human rights protocol based on Nsibidi. Nsibidi is an Asian is a Igbo, it's a ancient, it's not an ancient writing system. It's like, it's basically, it's still a modern because it still applies to this day, but it's a symbolic, basically, CBD is, basically the symbols of CBD are glyphs, and the glyphs are symbols and glyphs share some meaning, share meaning. So what's in CBD now? In CBD is a writing system, yes, but it's basically based on concepts. You use concepts to denotate or notate. To form denotate or denotate a notation, information, based on the pairing of verb, what I call verb noun pairing. So basically, the by mapping the bus, my idea was to map the bus to a rural architecture, rural computer systems, rural nodes that will always be online. And when they're online, they can also have food, water, shelter, and address your essential needs. Um, it sounds counterintuitive, but I don't want to think this way. I want to think about something that I can always access. But if I can always access it, that means I'm starving myself. So I can always change the code. I don't want to change the code, so that's why I made. So basically, the computers. I'm gonna have I have a computer here. I have a 3D printer there. I'm never using any of these things, but I'm gonna be using them soon when I have my compound, my condo. So my condos are gonna have this kind of design. Basically gonna have the not the bus topology, but basically have topology. Because there has to be always an internet connection. I don't want to lose an internet connection. If I lose an internet connection one day, I don't care what service I'm paying for. I just have to address it as my human rights, so I can stop people to stop treating me like trash. And yeah, so basically, you're gonna have a lot of things. You're gonna have a lot of things. You're gonna have drones, food delivery drones on a helipad. You're gonna have a two-story, three-story building. I prefer the two-story building. Breathing life and not working. Play stuff. So and you're gonna have a roof. You're gonna have everything look like you're gonna have solar powers. You're gonna have all of this things. But everything's gonna be solar powered, basically. So you can have some kind of charging station. So it's really cool. It's a digital hold philosophy of MucoOS. So MucoOS, M for Mike, FI, C for Miller, C for Charlie, O for Oscar. And that name is very beautiful. I love that name. So the goal is to have something that never loses internet connection. And I don't think it's very hard to do, but if you have security concerns, someone can hijack it. So the only problem is so if you don't lose internet connection, you have the other problem of security, and so you have a 2-to-1 private key. So because if two nodes have security, two nodes are real time. So if you're verifying, think of a transmission retrieval verifying. If you're verifying a node, two nodes at a time using the bus topology, like two nodes are current or blue, and they turn green. That means they're verified. And for example, if these two nodes here, one, two, one, two, let's say three. So if you three nodes, one, two, three, you have an area here. Oh, can I? So you have an area. So if you have, oh, I can't see this anymore. If you have one, one, two, three. You have a triangle, like, a small region of area that maps to a triangle. A triangle, and that triangle connects three things together. So it connects the message. So you can also, so listen, it's a peer-to-peer network of a subregion which can be verified via an edge closeness, like Dijkstraat algorithm, and that's an area that can never lose connection. So basically, that connection is an edge. Someone can stay in that physical space and never lose connection. So because it's a triangle, because it's a peer-to-peer network, but it's a triangle. So but it has a kind of a, oh, what's my schema? I lost a lot of work, but basically, it's like a wild man metropolitan, no, not a city, a wild area network, because literally it behaves like a wild area, and you have a MAC address, so you can't connect to this system because there's subnet masks of that region, and If I can't build this, that means I'm overthinking the stuff. I'm not thinking about stage properly, and I'm overdoing the work. But this is the bus topology model. Now, so you have this kind of triangles you can form. You can form subregions and sub triangles, and you can form the dynamic topology here. Yeah, which is a star. And if I can't do this now, I'm not Nigerian. I forgot a lot of being Nigerian. But I will not be wanting to break me. So let's get to work on my next video. Okay? Thank you for watching this video. So these are the topology models here. Yeah, these are the topology models. So look at it. I don't think it's gonna be impossible. Just gonna think if I'm gonna be doing it right or wrong. So let me just see if I can shrink down and do this properly. So can I mark it here? Okay. 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 So this is shaded region here. So basically, see those shaded nodes here? I've colored them in. So that's what I'm referring to. And if it refers to this kind of system of being connected, I want to be part. I really don't think I'm thinking about this correctly, but I'm still building a condo. So basically the condos, the condominium. So this area here, basically what I've shaded in here, yeah. Shaded in. This is the node. This is a node to computer. This one computer. This another computer here, and this another computer here. And because they're connected to, they have a 2-to-1 private key. They share the peer-to-peer in the topology, but the ones that are active, one that are closest, basically, if they're the one that's closer out of three of them, 1, 2, 3, have a peer-to-peer private key. And basically, because of that region space, they are connected by two. They have they share two public keys and one private key, and that's the idea. Because by sharing the security, I think it's more complicated. I think it's more complicated. So I am. So that's just idea there. I'm complicated. So let's go with this idea. Let's go with this idea. So basically, the more simpler it is, the better it is for me. Because I have to simplify the idea too. So that's the idea, but not necessarily simpler. So basically, the regional space is just like the space you stay, and it's a static space, so you can always have internet connection. Basically, it's a physical space master robot, and that's the idea. Thank you for watching this video. Thank you for watching this video. What's my recorder saying? Yes. Stop recording.